last year, and I probably will give you this, and it's a good thing to give you when we get to squares, but I want to show you what kind of how I talk about it as a family of things. We've split our polygons. You know, we did lots and lots of things with triangles and still have a few more things to do with triangles. And now we're doing a lot of things with quadrilaterals, which are probably the most, well, triangles and quadrilaterals are your most popular um, polygons in high school geometry. And so I've been saying it was a family. So let me show you this cutout I gave them last year on the day we did squares, because we've done parallelograms. But what you have to recognize is that plural, you can say rhombuses or rhombi. One is a rhombus, and we'll talk about those. When will I see you again? Friday. So we'll talk about, we've done parallelograms, but see, all of these are parallelograms. And a rhombus and a rectangle are parallelograms, but here's the interesting one. When you get to squares, a square is all of these. All of them are parallelograms, but a square is also a rhombus and also a rectangle. So all of these characteristics come down as we go. So everything we said about a parallelogram is true about all of these, plus they have a few extra characteristics. It only has two more characteristics here, and I think you probably know one of them for sure, and then the other one you may not know, but I think it's kind of obvious when you do it. They're stated here, and we'll do them in just a second. But that's where we're going. We're doing everything with these, and then we'll spend a little time with other quadrilaterals, trapezoids. I have done kites when we had time. I probably won't this year. It's just one of kind of those extra ones. But rectangles is, the main thing you want to recognize is it is a parallelogram. Now, what does that mean? Well, that means it has four sides. That makes it quadrilateral. It has four angles, adds up to 360. But look at all the things over here. Okay, I'll come right back to that. It's, oh, we got a bunch of them. Here we go. Opposite sides are parallel. Opposite sides are congruent. Opposite angles are congruent. Consecutive angles are supplementary. And diagonals bisect each other. So all of those are true. And if you have a true rectangle picture, it helps too. So we've got a rectangle on your geometer. We use it a lot of times as our reference point. We'll talk about the triangles around it. So your rectangle is over to the far right, and we'll draw it. I mean, you can draw a rectangle with a ruler pretty easily, but it's easier just to go ahead and do it this way. I'll call it rectangle ABCD. So two more rules. Number one, so we say two more rules added on to parallelogram. All angles are, what are they going to be? What do you know about a rectangle? What do you know about all the corners? They are congruent. They're all four going to be the same. They still match up with the idea that this is the same as this one, this is the same as this. They all add up to 360. These two add up to 180 and all that. But look at them. What do you know is in the corner of rectangles? They're right angles. All angles are right angles. Now, you remember how we marked that with a little square thing? As you step up and advance it even more, sometimes people even define it, and I don't know if this was in high school or if this was in college geometry, that we said it's a parallelogram with one right angle. And you think, well, that sounds a little weird. But if I only make one of these a right angle, remember, these two are the same, so they are both 90. And I know these add up to 180, which would make that 90, and then that would make that one 90. So it's kind of weird the way you say it. We say all of them are right angle, but you really only have to say one of them is a right angle if it's a parallelogram. Now this one you might not know, but you'll see it. The diagonals bisect each other. Oh, we already know that. Let me try that again. Diagonals are congruent. So I have a little ruler here. You can use your geometer. So we'll draw AC. Ooh, missed that one a little bit there. And we know BD. I can't hit that very well. So segment AC is congruent to segment BD. Now, because it's a parallelogram, we know, now look carefully, we know this is congruent to this because it's a parallelogram. We know this is congruent to this because it's a parallelogram, because the diagonals bisect each other. But then you're going to find out, because they're the same, this little piece right here is going to be the same as this one. See, it's going to be an isosceles triangle. This one's going to be the same as this one. So as they go around, you're going to actually find that all four of these are the same. If they're the same and they bisect each other, all four of those are the same. So there's a lot of little extra things there that we like. So let's do, I've got 3. I think we can get them done. The first one's arithmetic. The second one's, 2 of them are arithmetic, and one of them's doing segments, one of them's doing angles, and the third one's doing algebra. So number 1. And we just use the same picture all the way through. And we'll go ahead and draw the diagonals. This again may be a lesson you want to print, because I like to write on the pictures. Yeah, if you're struggling with rectangles, parallelograms, or anything, I would encourage you to, especially 35, print it, and we can write on it. That makes it a little bit better. This is rectangle PQRS. Knowing that all of them are right angles, I'm just going to mark one of them. You can mark all of them if you need to. Well, here's what they actually tell you is, let's see, I'm looking for my givens. Oh, now that's, okay. Because I have to see what it's asking for. So it's asking for that one. So it must give this one as 10. And it must give this one as 24 up here. But it's going to give me something else. No, actually, that may be all of it. Let's see. QR, it wants to know. And SR, we're going to call this point T right in here. And SR and SQ and PR and QT. Okay. I think that's all we have to have, which is kind of interesting as we go through it. Okay, do we know any of these to start out with? Do we know QR? Do we know SR? Do we know SQ? I don't think we know the last 3. We should know QR. How much? 10. Opposite sides of a parallelogram are congruent. That's where that comes from. See, these are congruent, not because it's a rectangle, because it is a parallelogram. SR, and I'm going to write them on there. SR is 24. Okay, again, opposite side of a parallelogram are congruent. SQ, now, we didn't get color pencils out. That's okay, we don't have to. I want you to take your pencil and just make this triangle right here a little darker for me. And I'm going to say triangle, I'm going to call it triangle SQR. And my question is, can I say that triangle SQR is a right triangle? Okay, why can I say that? Because it's a triangle. Does it have a right angle in it? Yes. Oh my goodness gracious. I need to find SQ. Now, if I can get SQ, PR will be the same because the diagonals are congruent here. Now, see, in a rectangle, it's obvious. You've got a short one and you've got a long one. They will not, so the reason these are the same is because it's a rectangle, not because it's a parallelogram. That's where it kind of gets a little crazy. But I know something called the Pythagorean theorem. I haven't done that one in a while, where the leg squared plus the leg squared equals hypotenuse squared. So if you look at our triangle SQR, and we know SR, and we know QR, which are the legs. Do you see it? Do you see that SQ is going to be our hypotenuse? Okay, so I'm just going to call that my X. I don't have any X's in this, so I'll just call that my X. So I've got 24 squared plus 10 squared equals X squared. I'll just call it, you could call it 8 squared for hypotenuse. And I'm going to do the arithmetic for you for time's sake. 576 plus 100 equals X squared. I'm going to flip that over and say X squared equals 676. Okay, now I don't know that we've done this. We've been doing this in Algebra 2. Okay, time out. Let me ask you a question. If I give you X squared equals 25, what's X? 5. And technically what you did is you took the square root of this side and the square root of that side. Have we done this? Okay. Now, you have to recognize, and I want you to be aware of, there actually are 2 answers, because that's quadratics. We do those in Algebra 2. May have dabbled in it in Algebra 1. Probably with COVID quarter last year, you may not have. But the thing is, you can't have negative links, so this one doesn't work here. So this is called the principal square root, just the positive one. And when we're talking about distance, we only do the positive. So if I do square root here, now if you use your calculator, it is a perfect square, and it's 26. Now, I don't know that one off the top of my head, but if you type it in your calculator and do the square root, you know how to do square root on this? I think you do the square root first and then the number, don't you? Yeah. Clear? Don't you just do square root, second, square root? Can you see it at all? Maybe a little bit. 676, enter. And we got 26. There it is. Okay, so we know now that and the hypotenuse is the longest side of a triangle. So this whole length is 26. Then what's PR? It's also 26. Now, what's QT? Okay, and I marked it up here, from the parallelogram, we know that the diagonals bisect each other. So I know this is the same as this. If the whole thing's 26, then what is QT? 13. Now, here's what's really interesting. This is 13, this is 13, this is 13, and this is 13. But recognize that these 4 are not going to be right triangles. You cannot do Pythagorean theorem on any of these. They are isosceles, but they're not right. They're not right triangles. Only the big ones, like this one, SQR and SQP and PRQ, as long as you have one of the corners in it, that sets you up.